Okay, example number 5. We have pure helium gas that's emitted into a tank, as you can see in this picture. This is a movable piston that can move up and down, and we have an initial pressure, volume, and temperature given, as shown right here. So I'll write them down now. So this is the initial state variables of volume, pressure, and temperature shown here. And now we know that it will decrease in volume and increase in pressure, and we are asked to find the final temperature. So let's show a picture of that scenario as well. And we can apply the ideal gas law from this initial state to this final state. So what I've done here is written the ideal gas law twice on top and bottom for the initial state and for the final state, and then we'll cancel out what we know is constant. We'll assume that there are the same number of moles at the beginning and at the final state because there hasn't been any gases lost, and that the gas constant is constant as well. And we'll rearrange our equation for solving for T2, and then we can substitute in. And you'll notice I don't change my these kilopascals to pascals, because really what I would be doing is simply multiplying top and bottom by 1,000. It wouldn't make any difference. So pressure 2 is 350 kilopascals, or you could say 350,000 pascals. And then we have 200 kilopascals, or 200,000 pascals. Our volume finally is 12 times 10 to the power negative 3 meters cubed. And our initial volume was 15 times 10 to the power negative 3 meters cubed. And then our our initial temperature was 300 Kelvin. So, multiplying on your calculator, you will get 420 Kelvin. Now, I should point out that these pictures are not quite right in the fact that the pressure has increased. And in order to increase the pressure, there have to be a bit more force pushing down here than there was initially down here. So there's probably more mass or maybe some external force pushing down on here to create a higher pressure. Had it been just this shaft here pushing down and then the same shaft down here, then it would be the same pressure. So we do have to acknowledge that the tank's essentially being squeezed, creating a higher pressure. So there's more external force down in this final state. Okay, and that's it for this example.